This is GAS's video number 4 on the ideal gas law. By the end of this video, you should be able to calculate pressure, volume, N, which is the number of moles, and temperature for a gas under non-changing conditions. You should have your GAS's video number 4 worksheet, a pencil, and a calculator. So far, we have calculated temperature, pressure, and volume for changing conditions, but you also want to be able to find out what it is under non-changing or constant conditions. The ideal gas law is the following: PV equals nRT. As I just said, this represents what is called the ideal gas law. Under it, P is for pressure, V is for volume, N is for the number of moles, and T is for temperature. In order to make this relationship work, or for PV to be equal to N and T, a gas constant is required. R is the gas constant. Being a constant, it is going to have a constant value. The value is 0.0821, and the units are liters, atmospheres over moles, Kelvin. Now you might want to know why these units are used. Let's take a look at this equation. If we rearrange the variables so that we get R by itself on one side, we will see the following. We're going to divide by NT so that R is equal to PV over NT. P is pressure in ATM. V is volume in liters. N is the number of moles in moles. And T is the number of units in Kelvin. By using these units, PV, N, and T will correctly cancel its units. Just make sure that you're using the units of ATM, liters, moles, and Kelvin. Let's do our first example problem. A 250 milliliter flask has a pressure of 0.98 ATMs at a temperature of 24.7. Determine the number of moles of gas in the flask. Our first step is to list our units. In all cases, you can go ahead and plug in the gas constant, since it will always be the following. Okay, our pressure is 0.98 ATMs. We have a volume of 250 milliliters, and number of moles is our unknown, and 24.7 degrees Celsius is our temperature. Now we want to make sure the units are the correct units. Pressure in ATMs, gas constant in ATMs, that is good. Volume in milliliters, gas constant in liters, we need to convert. Remember, 1,000 milliliters equals 1 liter. So we want to bring down the milliliters so they can cancel. Put the liters on the top, so 250 times 1 divided by 1,000, 0.25 liters. Next, temperatures in Celsius, gas constants in Kelvin, we need to convert. We do that by adding 273, and we get a temperature of 297.7 kelvins. We're now ready to use the ideal gas law. The ideal gas law is PV equals nRT. We're solving for N, so I'm going to rearrange the equation so that I can get N by itself. I do that by dividing both sides by RT. Now N is equal to PV over RT. Since my units match, I'm ready to go ahead and plug it in. When I plug in, I'm plugging in the number and the unit so I can show later that they cancel correctly, and therefore what my final answer will be unit-wise. At this point, my ATMs cancels, they're the same on the top and the bottom. Liters cancels, same on the top and the bottom. And the Kelvin cancels. Moles would be my final unit. It's in the denominator of the denominator, which makes it the numerator. My final answer is going to be 0.010 moles. Go ahead and try this in your calculator. Make sure you're getting the correct answer out at the end. If you're inputting it into your calculator incorrectly and cannot figure out how to do it so that you get this answer, you need to see somebody who uses your calculator or your teacher. Example number 2, a little bit different. A student has 16 grams of oxygen, notice that it's diatomic, at 23.8 degrees Celsius and 785 torrs. What is the volume of this gas in liters? We're going to start off by listing the units or what we've been given. As always, you can go ahead and fill in the gas constant because it is always the same. Okay, pressure was 785 torrs. What is the volume? That is our unknown. They did not give me the moles. And the temperature is 23.8 degrees Celsius. Let's check to see if our units match. Pressure in torrs, but the gas constant's in ATMs. So I'm going to go ahead and change this into ATMs. By doing it this way, my torrs, which are the same on the top and the bottom, will cancel. And I end up with a pressure of 1.03 ATMs. Next, my temperature is in Celsius, but the gas constant is in Kelvin. So I'm going to add 273 to this to convert it into Kelvin, which gives me a temperature of 296.8 Kelvin. Now I need to find my number of moles. What they gave me was my grams. I'm going to use grams to mole conversion in order to find my answer. To do this, you need your periodic table and find the molar mass off the periodic table. For oxygen, the molar mass is 32 grams per mole. On the periodic table, the molar mass of one oxygen is 16, but since it's O2, I'm going to double that to get 32. Now to do my conversion. I have 16 grams of oxygen given. The grams drops down, and the moles goes on the top. Looking at my molar mass from the periodic table, I know it's 32 grams per 1 mole. 32 grams. So 32 goes with the grams per 1 mole. 1 goes on the top. 16 times 1 divided by 32 is 0.5 moles. So now I know the number of moles, and I'm ready to solve the problem. Once again, my ideal gas law, PIVNERT, PV equals nRT. I want to solve for volume, so I'm going to divide both sides by pressure to get volume by itself. Now I'm ready to go ahead and plug in my numbers since I have all my variables and the units are matching. Oops. Made a mistake there. I should be plugging in R, and R is 0.0821. Pressure will go on the bottom. Now let's see if the units cancel out correctly. Moles on the top and bottom, that cancels. Kelvin on the top and on the bottom, that cancels. And ATMs on the top and the bottom. I would have found, had I not changed where my pressure reading was, that my units would not have canceled correctly. So 0.5 times by 0.0821 times by 296.8 divided by 1.03, 11.8 liters is my final answer.